now the shipping forecast issued by the Met Office at 2343 on Wednesday the 5th of January. There are warnings of gales in Viking, south of Zero, Forties, Cromarty, Fisher, German Bight, Biscay, Trafalgar, Finisterre, Seoul, Shannon, Rockall, Malin, Hebrides, Bailey, Fair Isle, Faroes and southeast Iceland.
The coastline is the scene of an ongoing battle between land and sea. But like all battles, this one ebbs and flows, and as it does so, the shape of the coastline changes. At times, the speed of these changes is dramatic. Many stretches of coast are under siege, fierce storms causing millions of pounds worth of damage. Along some parts of the east coast of England, land is being eroded at the rate of 2 meters per year, making permanent seaside housing impossible. At other points along the coast, the land is increasing its hold. Obstructions like groins, islands or headlands slow the sea and allow sediment to be built up. This way, each feature of the coastline serves as a record of the ongoing battle. By looking carefully at these features, we can see how the processes of erosion, transportation, and deposition have shaped them over many years. At many points along the coast, the land is in retreat, being pushed back and eroded away by the sea. Erosion depends on what type of rock it is and how powerful the waves are. Large waves have tremendous energy. As wind blows across the ocean, waves are pushed up. The longer the fetch or the stretch of water exposed to the wind, and the faster the wind, the larger and more powerful the wave will be. For this reason, nearly all erosion happens during storms. During storms, waves push out loose rocks and toss them onto the cliff face. The tumbling rocks wear away the base of the cliff. This process, known as undercutting, results in the formation of caves. A very special case is Fingal's Cave, on the Isle of Staffa, north of the Isle of Mull on the Scottish west coast. The cave walls are made up of columns of volcanic rock. As the lava cooled, it shrank, forming very regular cracks called joints. Over time, water has entered and dissolved enough rock to widen the joints, forming flat-faced columns. These columns also have horizontal joints, allowing the rock to break off. It's a rather unique set of joints, which have led to the formation of an incredible cave. Over time, the caves carved out by the sea gradually collapse or are eroded away to form arches, tunnels or blowholes. In this example from Warrawood, New South Wales, wave movement has eroded out a tunnel along a line of weakness. As the sea continues to erode along the lines of weakness, eventually the cave roof collapses, leaving pinnacles. This is how the old Harry Rocks in Dorset were formed. The 12 Apostles in Victoria, on the southern coast of Australia, were once caves whose roofs collapsed. These are the Needles on the Isle of Wight. Along much of England's south coast, the landforms are shaped from bands of chalk, clay and limestone. Along the Dorset coast, a band of hard limestone forms a natural barrier. At Lulworth Cove, when the sea did enter, it quickly eroded the clay band, and is now attacking the chalk cliffs behind. Nearby is the stairhole, the start of a bay being formed as once again the sea breaks through the barrier of limestone. Originally, the ground in this area was made up of several layers with limestone under, chalk and clay. Over time, the ground folded and the layers were tilted. This tilting resulted in a layer of resistant limestone fortifying the land against the sea's attack. This is very clear at Manor War Cove near Durdle Door. The band of strong limestone, the bay where the clay has been eroded, and the chalk being eroded slowly, leaving cliffs. Next to the remnants of the soft clay are vertical bands of limestone. The angle of the bands affects the rate of erosion by the sea. This ridge is part of the limestone band. The layers are almost vertical. It erodes to form cliffs and spectacular formations. In this case, the tilting is about 45 degrees and the erosion has produced a slope rather than a cliff. Next, we are going to find out how ocean waves produce erosion on land. These potholes, for example, are shaped during storms. Waves grind rocks round in depressions, slowly forming larger holes. If we look at the sea where the coastline is made of hard rock, there are rock platforms where erosion is occurring above the water and not where the waves hit. This doesn't seem logical. It's because salt spray causes weathering. The process begins when spray falls onto a rock and then soaks in. If it dries, salt crystals are formed and these prize sand grains out of the rock. The rock is then coated with a fine layer of sand that will be removed in the next storm or high tide. This process, known as honeycomb weathering, can produce a fantastic array of patterns, like these examples from around Sydney. Where the rock is white, the iron oxide has been leached out of the rock. In the case of sedimentary rock, different layers are eroded at different rates. Shale is quite soft. The strength of sandstone varies. The redder the rock, the more iron oxide it contains, and it will be stronger as a result. This is West Bay on the south coast of England. Here resistant bands have been left jutting out as the softer parts are worn away. Moving water will move sediment, but it depends on the speed of the water and the type of the sediment. With waves, we are interested in how the water is moving at the bottom, where the sediment is. This wave tank with coloured drops shows the direction of movement in various parts of the wave. On the surface, the particles of water move around in circles. Lower down, the paths become more elliptical, and on the bottom, the water moves back and forth. The amount of movement on the bottom depends on the size of the wave and the depth of the water. Waves break on the shore when friction from the seafloor slows this circular motion, and the crest moves forward onto nothing. This is not a wave anymore. It is a rush of water, and it carries sand along with it. This sand is carried up onto the beach, and as the water rushes back, it also takes some sand back with it. Small waves bring sand up the beach and don't carry much back to the sea. This is because some of the water sinks in and there isn't enough backwash. And it's exactly the same on a pebble beach. A rush of water moves the particles forward, the water sinks in, and the pebbles remain on the sand. Smaller waves which build beaches up in this way are known as constructive waves, and usually occur during the summer months. During rougher weather, when the waves are bigger, plunging waves occur. These waves create a larger backwash that carries material away, thereby cutting into the beach. These are called destructive waves. It's quite normal for beaches to be eroded during storms and rebuilt during calmer weather. This example from New South Wales shows where destructive waves from two storms have cut into the dune and taken the sand out to sea. The beach will recover in fine weather. Frequently, the direction of the prevailing wind causes waves to approach the shore at an angle. As each wave breaks, particles are carried up the beach, but at a slight angle. As the water flows back down the beach, they do not return to the same position. If this process is repeated over several years, the sand will be moved along the shore in a process known as longshore drift. Sometimes the sand moving along the beach forms a bar across the mouth of rivers. At Chisel Beach, the pebbles and sand have been pushed right across a bay by longshore drift, producing lakes and marshes. As waves come in from the North Sea, they strike the coast at an angle. Some of the fastest erosion in the UK is along this part of the Norfolk coast. We can see the direction of longshore drift by the shape of the sandbanks and the direction rivers have been pushed by the drifting sand. Over the years, this river has moved way off course. Here, the longshore drift has eroded 4 miles of beach so badly that it had to be recharged at a cost of £5 million. Thousands of tons of shingle and sand were used, raising the height of the beach along the seafront. Experts believe this treatment will protect the shoreline for almost 60 years. In front of towns on this section of the coast, the process of erosion can be slowed down or even reversed. Walls called groins are built out into the sea to slow the water and allow the sediment to deposit. You can see the difference where there is no groin. The beach is narrower. The longshore current has not allowed as much sand to accumulate. At West Bay in Dorset, training walls are holding the mouth of the river in place. The beach is building up on one side of the wall and being stripped away on the other. Most fishing villages use training walls. These walls keep the river mouth narrow in order to give it enough flow to wash out sand building up at the entrance. There is an old saying that headlands attract waves. On headlands, the energy of waves is focused, and the waves become larger than on other parts of the coast, and the large waves cause erosion. If we look at the beach behind the headland, we can see that the waves are spreading out and sand is collecting. But why are the waves here much smaller, and why are they curved, in turn shaping curved beaches? The cove at Manor War gives part of the answer. If waves come through a gap, they will spread out in all directions. This spreading out is called diffraction, and it occurs in deep water. In shallow water, waves change direction for another reason, called refraction. Waves coming from the ocean swing around headlands because the shallow bottom near the headland slows the waves. The waves in deeper water keep on at the same speed, forcing the wave front to swing around, always in towards shallow water. Sometimes you have to look carefully, but it is always there. If you look at waves passing a rock, you will see them bend in towards and behind the rock. Again, this is refraction. The curving of waves in shallow water is a combination of refraction and diffraction. If there's any sand available, it will be deposited here and begin to form a spit. If the spit reaches an island, it is known as a tombolo, or tide island, because the island is tied to the shore. The shallow water shapes the waves, which then shape the beach. This is a time-lapse of a beach being recharged by trucks filmed over several weeks. We can see that any part of the beach that juts out attracts the waves and is eroded away until the beach has an even curve. Given a chance, waves will straighten a coastline. Thus waves cut off headlands and fill in bays. This straightening process has gone on for millions of years. So, why isn't the coast all straight? Well, many factors are at work. Coasts are rising and sinking, sea levels keep changing, and volcanic activity changes landforms. The coast of Scotland has been scoured by glaciers, and during the Ice Age it sank beneath the weight of an ice cap a mile or more deep. Now the ice is melted, the land is gradually rising up again. At Start Point, the line along the cliffs in the background shows where ancient beaches and wave-cut platforms have been raised up to a height about 50 meters above the current level of the sea. When people live on the coast, they don't want to be part of the erosion process and often build walls to protect their property. However, sea walls can result in sand being washed out, leaving the rock exposed. This effect occurs as waves hit the wall and are reflected. A huge surge of water scours the sand or pebbles from the beach. The bigger the waves, the more erosion there is. After the storm, sand must be returned to the beach. It's a very costly operation. Sand dunes are natural deposits of sand along the shoreline, which help to protect the beach from the ocean's destructive force. Wind-borne sand is trapped by the grass and held in place. Where the grass has died, the sand will usually blow away, leaving what is called a blowout. At Perranporth on the Cornish coast, the dunes are being eroded by people walking on them. Paths allow the sand to blow or wash away. If this continues, eventually the dune and then the beach will be lost. All around the world, communities are preserving their dunes to save their beaches. Replanting dunes is now seen as an effective and environmentally friendly alternative to building costly seawalls to defend towns along the coast. The scars of old battles litter our coastline, each one with its own unique story to tell. But as the battle goes on, even these old remnants are being reshaped.
Now the shipping forecast issued by the Met Office at 0730 on Thursday the 6th of January. The seas will be calm for Shannon, Malin, Hebrides, Bailey, Fair Isle, Faroes and southeast Iceland.